Good morning, students. This is your lecture 6 of concrete technology. So, last class we had studied about types of cement, right? In there, we finished studying about ordinary Portland cement, and then now we will look at the second type of cement, and this cement is also known as rapid hardening cement. Also, we call it as RHC in short form. Okay. So, what is like the speciality of this cement? Okay, let us see. In this cement, high content of C3S is present, and finer grinding enable it to attain greater strength at early ages. Okay, so if you remember when we studied about Bogue's compound, we studied about C3S, yani ki tricalcium silicate, then dicalcium silicate, C2S, and we had studied that C3S is more responsible for early strength, and also C3 it develops high heat of hydration compared to C2S. Okay, so we know that C3S is like hydrates faster and gives more heat of hydration, due to which early strength can be achieved faster. Because of this reason, C3S content is more in this type of cement and C2S is comparatively less. Why? Because if you look at the name of the cement, what does it say? It says it is rapid hardening cement. Rapid. Okay, what is rapid? What is meant by rapid? Tell me. Rapid means जल्दी, जल्दी होना है ना. रैपिड एकदम जल्दी से जल्द होना. सो अगर हमें जल्द से जल्दी स्ट्रेंथ चाहिए, जल्दी से हमारा सीमेंट सेट हो, हार्ड हो जाए, स्ट्रेंथ जल्दी आए, जल्दी, तो जो सीमेंट जल्दी से जल्दी हार्ड होगा उस सीमेंट को हम रैपिड हार्डनिंग सीमेंट बोलता है. और हमें ये पता है कि C3S जो है इज़ रिस्पॉन्सिबल फॉर अर्ली स्ट्रेंथ एंड इट इज़ रिस्पॉन्सिबल फॉर हायर हीट ऑफ हाइड्रेशन कंपेयर टू C2S. तो जो कंपाउंड हमें ज़्यादा जल्दी अर्ली स्ट्रेंथ देगा, जो कंपाउंड हमें ज़्यादा हाइड्रेट होने में हेल्प करेंगे, तो हम उसी कंपाउंड की कंटेंट ज़्यादा रखेंगे ना. और जिस केस में हमें पता है कि C3S कंटेंट, C3S से हमारा अर्ली स्ट्रेंथ जल्दी आ सकता है. दैट्स वाई इस सीमेंट में C3S कंटेंट ज़्यादा है कंपेयर टू C2S. And also the finer grinding, and if you even compare, the particle size of rapid hardening cement is very fine, very small, and because of which, if the particle size are very small, then it will get greater surface area. So if you have more greater surface area, then automatically there will be more surface area from where hydration reaction will take place, and more hydration will take place, because of which high heat of hydration produced will also be more. Or if hydration reaction happens faster, then obviously your cement will start to harden faster. Okay, so you have to remember these two things here. C3S rapid hardening cement has higher C3S content. Sorry for my pen, I wanted to underline it. And it is finer grind. ठीक है, दो पॉइंट याद करना है. C3S में RHC सीमेंट में C3S ज़्यादा है. Why? Because C3S helps in faster hydration and finer grinding. Finer grinding क्यों? Because if the particle size are very fine, then it gets more surface area, because of which hydration reaction can occur faster and strength can be achieved faster. Okay, that's why greater early strength can be achieved. Now let us see the properties. Properties are similar to OPC only. Okay, यानी कि उसका fineness जो है, it should not exceed more than 10%. Okay, not more than 10%. Soundness, it should not have more than 10 mm. Okay, जैसे हमने OPC में पढ़ा था similarly. And इसका भी setting time, initial setting time not more than 30 minutes. Final setting time not more than 10 hours. Okay, now let us see the uses of RHC. Okay, so since we know that RHC hydrates faster and hardens faster, and we can achieve early strength very fast, ठीक है? So obviously RHC will be used for those works where we want something fast, ठीक है? Where we want the concrete to set fast. For example, अगर हमको रोड रिपेयर करना है, ठीक है? तो रोड रिपेयर करना है तो obviously let us consider concrete road, all right? So when it comes to repair of road, everything we want it as fast as possible, right? Because the vehicles, it is used for vehicle, and vehicles are not something that travels today and won't travel tomorrow. It keeps on traveling continuously, which means road repair ke liye we want something, for repairment of road or for construction we want something fast that will give fast result. So in such case we can use RHC. Why? Because RHC hardens fast, it achieves early strength faster, so because of that we can use RHC. Okay, so let us see, let us read this. RHC is used where high strength is desired shortly, ठीक है, जहाँ पर high strength जल्द से जल्दी चाहिए, and formwork is to be removed as early as possible in order to reuse it. Now this point, I don't know if you have studied this word or not, but let me explain. Formwork क्या है? Formwork are the temporary structures in which concrete are poured. Okay, जैसे कि आपने देखा होगा any building, when there is a construction of buildings, okay, जब वो लोग when they make column, first they will put, what do they put? They put a formwork, right? They put a formwork. Formwork क्या होता है? Either it is made up of wooden, or either it is made up of wooden or it is made up of metal, right? ऐसा formwork होगा, आपने देखा होगा, right? Formwork, this is your formwork. तो इसके अंदर हम क्या डालते हैं? इसके अंदर हम कंक्रीट डालते हैं, ठीक है? तो फॉर्मवर्क क्यों यूज़ करते हैं हम? फॉर्मवर्क मेनली इसलिए यूज़ कर, इट्स अ टेम्पररी स्ट्रक्चर इन विच कंक्रीट इज पोर्ड, ठीक है, जब तक कंक्रीट सेट ना हो जाए. अगर हमें रेक्टेंगुलर शेप का कॉलम चाहिए तो हम रेक्टेंगुलर फॉर्मवर्क लगाएंगे. अगर हमें सर्कल वाला कॉलम चाहिए तो हम गोला वाला फॉर्मवर्क लगाएंगे, राइट? फॉर्मवर्क विल बी देन राउंड, लाइक राउंड. तो इसके अंदर हम कंक्रीट लगाते हैं. So formwork mainly क्यों use होता है? Formworks are the temporary structures that are being used where we pour the concrete and later when the concrete sets we remove the formwork, ठीक है? तो एग्जाम्पल, अब सच केसेस जहाँ पर मानो फॉर्मवर्क आपको जल्दी से जल्दी यूज़ करना है, आपके पास कम टाइम है और आपके पास कम फॉर्मवर्क है, तो हम क्या यूज़ कर सकते हैं? उस केस में हम RHC सीमेंट यूज़ कर सकते हैं, क्योंकि उस RHC सीमेंट को ज़्यादा टाइम नहीं लगता सेट होने में, बिकॉज ऑफ इट्स हाई अर्ली स्ट्रेंथ डेवलपमेंट एट अ वेरी शॉर्ट पीरियड ऑफ टाइम वी कैन फॉर्म, वो जल्दी हार्ड होगा तो हम फॉर्म वर्क को जल्दी से जल्दी रिमूव कर सकते हैं. वी कैन रिमूव, फॉर्म वर्क कैन बी रिमूव्ड एज अर्ली एज पॉसिबल. ओके, सो कहाँ यूज़ करते हैं? इन शॉर्ट, RHC आर बीइंग यूज्ड इन सच प्लेसेस वेयर you need high strength as fast as possible. Secondly, where we can remove formwork as early as possible, ठीक है? If maybe because of shortage of formwork or maybe because the construction work is very big और formwork कम पड़ा है, तो हमें जल्दी से जल्दी formwork को और जगह पे यूज़ करना है, तो उस केस में हम RHC सीमेंट यूज़ कर सकते हैं, so that we can remove formwork as fast as possible. Now let us see the second point. It is used for road pavements or road repair where it is important to open the road to traffic without delay. Okay, just like I explained, like traffic roads are such places where you want things to be repaired as fast as possible, right? So in such cases we can use RHC cement because it does not take much time to set, and early strength, the highest early strength can be achieved. Third point, let us see. It is preferably used in industries where manufacture of concrete products in the form of slabs, block fence, post, electric poles. Okay, so it is like there are places, I don't know if you have heard or not, there are some industries where they make ready-made slabs, ready-made कॉलम्स रेडीमेड ब्लॉक फेंस ऑफ कंक्रीट स्ट्रक्चर्स. ठीक है, वो आपको स्लैब बना के रेडीमेड स्लैब वगैरह बना के देंगे और वो स्लैब जो गाड़ी वो लेके जहाँ पर कंस्ट्रक्शन साइट है वहाँ पर वो लेके चल जाएंगे और वहाँ पर स्ट्रक्चर लगा देंगे. मतलब यू डोंट हैव टू you don't have to cast the concrete at site. Okay, आपको रेडीमेड एकदम रेडीमेड कॉलम रेडीमेड स्लैब बना के देता है. तो ऐसा इंडस्ट्रीज भी है. So in such places, in such industries, there also rapid hardening cements are used because we want जहाँ पर जल्दी है, we want to manufacture things fast. We want to manufacture slabs, columns, and all very fast. So in that case, we can use RHC. It is also used for cold weather concreting. Now let us see the fourth point. It is also used for cold weather concreting because rapid evolution of heat during hydration protects the concrete against freezing. Okay, so now what it says is in cold weather. Okay, we know, if you remember, we had studied that hydration reaction also depends upon the temperature. If the temperature is high, then it helps in early hydration and it helps the hydration reaction to occur fast. But in places where it's very cold, okay, when the temperature is very cold, the hydration reaction also slows down. And if the hydration reaction slows down, then it takes more time for the cement to set, which means it takes more time for the cement to harden and gain its strength. So in such case, when we know that it's going to take too much time, but we want things to be done as fast as possible. So in such case, we in cold weather concreting also we prefer rapid hardening cement, because rapid hardening cement helps in faster hydration reaction, also in early strength development. The development of strength is faster. Now the third type of cement we are going to study is low heat cement. Okay, in short we also call this cement LHC. I would want you guys to remember the abbreviation of these cements, because most of the time they might not mention like low heat cement or like rapid hardening cement. They'll just say OPC, RHC, LHC. So you should know the abbreviations of these cement and you should also know the full form of these cements. Alright, now let us see low heat cement. First point, it develops less heat of hydration. Okay, so like the name suggests, low heat cement, मतलब क्या समझ में आ रहा है आपको, जो सीमेंट जो होगा उसमें हीट कम होंगे. ओके, सो ऑब्वियसली इट डेवलप्स लेस heat of hydration, यानी कि when the hydration reaction will occur, the heat development will be very less. Now why is this? Why there is low heat of hydration produced in low heat cement? Now let us see the reason why. Okay, because it contains low percentage of C3S, which hydrates quickly, and higher percentage of C2S and C4AF, which hydrates slowly. Now again, let us move back to the properties of Bourke's compound. If you remember, I had explained the difference between C3S and C2S very nicely, where I had also said that C3S hydrates quickly, whereas C2S hydrates slowly, because of which C2S is also responsible for later strength. Okay, so obviously if rate of hydration is slow, then the rate of heat of hydration, rate of evolution of heat will also be less, right? So because of that only this cement is known as low heat cement because it contains higher percentage of C2S, यानी कि C2S content ज़्यादा है और C3S कम है. और C2S का property क्या है? C2S hydrates very slowly, and C2S, because of which, and if the hydration reaction is slow, then the rate of development of heat will also be very less. The evolution of heat will also be very less. That's why this is called low heat cement. Okay, so you can remember this as like opposite of rapid hardening cement. That will be easier way to remember. RHC में क्या केस था? RHC में C3S ज़्यादा था, C2S कम था. लेकिन लो हीट सीमेंट में क्या है? C2S कंटेंट ज़्यादा है और C3S कंटेंट कम है. ठीक है, और प्रॉपर्टी भी उल्टा है. RHC में जल्दी हाइड्रेट होता था, लो हीट सीमेंट में हाइड्रेट स्लोली होगा और हाइड्रेशन, हीट ऑफ हाइड्रेशन भी बहुत कम प्रोड्यूस होगा. So now let us see the properties. Properties are more or less the same. Okay, the fineness, maximum fineness that's allowed is 10%. Soundness, its expansion is not more than 10 mm. Okay, setting time, initial setting time should not be more than 30 minutes and final setting time should not be more than 10 hours. Now let us see the uses. So since it produces very low heat, okay, let us keep that in mind, that low heat cement produces very less heat like the definition says. So obviously it will be used in such structures which demands less heat production, right? Like example, let us see now. Uses. It is used only in large mass concrete works such as dams, bridge abutments and retaining walls. Okay, so where are low heat cements used? They are used mostly in mass concrete works. Now why is it? Okay, let me explain you why. Whenever there is mass concreting, okay, mass concreting means very big structures like dams, bridge abutments and retaining walls. These are like big structures. So whenever there are big structures being constructed, then you should know that the hydration reaction that will be occurring will also be huge. The hydration reaction that will be occurring will be a lot of hydration reaction will be occurring, because of which the heat evolution, the amount of heat of hydration produced will be also very much. And we know that if the heat of hydration produced is too much, if heat of hydration is too much, then it might cause cracks in the structures. Okay, like for example, what actually happens is, if this is a dam, okay, this is your dam. Let me construct this dam. This is a big dam. Okay, so what happens is, now this is a concrete dam. Okay, now your structure is being made, but sometimes what happens is the hydration reaction keeps on occurring. It's not like a one-day process, right? So when the hydration reaction is keep occurring, the heat will also be evolved. The heat will be evolved from everywhere, right, like this. So the outer structure, this outer structure from where the heat is being evolved, heat is being released, will be cool. वो तो ठंडा हो जाएगा, ठीक है, जो बाहर का है. But the inner structures, okay, in inner also there is concrete, right? So wherever there is concrete, hydration reaction is happening. So in the inner structure also hydration reaction is happening, and heat is also being released. Heat is still being released, okay, which means this part, the inner structure of the mass concrete structures, will be very hot compared to the outer structures. So you know when there is a temperature variance in any case, okay, when there is a temperature variance, like you can see outside it's too cold and inside it's too hot, then because of that there might be uneven cracking. Okay, whenever there is uneven expansion, uneven contraction of concrete, obviously there will be cracks that will be developed. So we don't want this to happen. This is the reason why we prefer to use low heat cement. Why? Because we know that low heat cement produces less heat of hydration comparatively. Okay. So let us see the other uses. So that's why in any mass concrete works we always prefer low heat cement so that we can prevent any type of cracking. Second part, let us see the second. In crack resisting structure, like I just explained, any structure where you might find there might be cracks produced in long term, so in such cases we will use low heat cement. Third point, it is also used in works where the rate of heat generation must be kept to a minimum. Okay, so any kind of work, any kind of structure where you don't want too much heat generation, too much generation of heat, in such structures also we prefer using low heat cement. And the fourth point, it is not used in thin structures as the strength development is slower and long curing, thereby wasting time and money. So you should also remember where the structure is not used. If the concrete is thin, like any thin structure, let us say slabs or small columns and all you want to make, that if you use low heat cement, the strength development will be very very slow first thing, and curing time will also be very long. मतलब कि आपको उसको strength जब तक I hope you know what is curing. Curing means, what is curing? जब हम उसको कोई भी स्ट्रक्चर को पानी के अंदर रखते हैं, ठीक है, और एनीथिंग व्हेन वी कीप द कॉन्क्रीट स्ट्रक्चर वेट. फॉर एग्जांपल आपने देखा होगा जब कोई भी जहाँ भी कॉन्क्रीट रोड अभी अभी बनाया होता है उसको हम कभी भी ओपन नहीं छोड़ता है, इधर उसको पानी के अंदर रखेंगे कॉन्क्रीट स्ट्रक्चर को, और उसके ऊपर वो रैक्स रख देते हैं, है ना, जहाँ गनी बैग्स रखते थे उसके ऊपर, तो उसको वेट बना के वेट गनी बैग्स रखते हैं, राइट. तो सिमिलरली तो वो क्या है, वो क्यूरिंग प्रोसेस होता है, ठीक है. जब हम कोई भी कॉन्क्रीट स्ट्रक्चर को हम एक प्रॉपर मॉइस्चर और प्रॉपर टेम्परेचर में रखते हैं, कैसे रखते हैं, उसमें इधर पानी के अंदर रख देंगे या फिर उसको कवर कर देंगे वेट गनी बैग्स या वेट प्लास्टिक शीट से. तो ऑब्वियसली अगर थिन स्ट्रक्चर्स है, ठीक है, तो बेवजह अगर हम लो हीट सीमेंट यूज़ करेंगे तो स्ट्रेंथ डेवलपमेंट स्लो होगा, क्यूरिंग के लिए भी बहुत लंबे समय के तक रखना पड़ेगा, और विच वी डोंट वांट बिकॉज दैट्स जस्ट गोइंग टू वेस्ट आवर टाइम एंड मनी. So in such cases, like in thin concrete structures, we don't need to use low heat cement. Now let us see pozzolana cement. Okay. So pozzolana Portland cement. This is another very famous cement that is being used apart from OPC. I don't know if you have heard or not, but we call it PPC. Okay. Pozzolana Portland cement. Now let us see the properties of pozzolana Portland cement. Pozzolana is a siliceous material containing up to 80% of 80% of pozzolanic material. Okay. So what is pozzolana? Pozzolana is actually a siliceous material. Like it is a siliceous material, matlab it is like a soil. Okay, it is like a soil, how to say, it is like a soil, it has a soil type of property. Okay, so it is like a material which is almost like soil wala property, and it contains very high amount of clay, up to 80%. So when this pozzolana is combined with cement, then it possesses lot of a very great cementitious property. It shows very good cementitious properties. Okay, so in the manufacture of this type of PPC, when we manufacture PPC, okay, let us see this point. 30% of pozzolanic material is added to OPC clinker and the mix is thoroughly grinded. So when we make PPC, what do we do? Almost 30% of pozzolanic material we mix with the cement clinker. Okay, when cement ko, what is clinker? जब हम सीमेंट बनने से पहले सीमेंट को जो जब पीसेस उसको ऐसा लम्प फॉर्म होता है. ओके, when we manufacture cement, in the end we have cement clinkers. Okay, we have cement. Wait. If I show you, see, cement clinkers. When we manufacture cement, okay, what do we mix? We mix lime, we mix silica, we mix alumina, we mix ferrous oxide. So when we mix all those ingredients, okay, and when they are heated at a very high temperature, then this kind of lumps, this kind of balls like structure, clinkers are being formed. This is okay. तो जब हम इसको ग्राइंड करेंगे, when we grind these clinkers, then we get, what do we get? Then we get cement. Okay, if we grind, उसको ग्राइंड करने के बाद हमें क्या मिलता है? सीमेंट मिलता है. ठीक है, तो जिस समय हम सीमेंट बनाते समय, while manufacturing cement, when the clinkers are being formed, इस clinkers में हम क्या ऐड करेंगे? We are going to add, what are we going to add? We are going to add 30% of pozzolana material. We are going to add 30% of pozzolanic material. Okay, and then both of them are mixed and grinded thoroughly. Okay, then that cement is known as PPC. Okay, so PPC में क्या है? इसमें 30% pozzolana है and 70% OPC mixed है. Okay, now let us see. PPC provides higher resistance to chemical agencies and attack by water. So usually PPC have a lot of advantage over OPC. Why? One of the best advantages is because it possess higher resistance to chemical action and attack by sea water. कभी कभी आपका सीमेंट अगर सी वाटर के केमिकल्स वगैरह के साथ रिएक्ट करे या फिर सॉइल के केमिकल्स के साथ रिएक्ट किया तो वो ख़राब होने का चांस होता है, लेकिन पीपीसी जो है वो ज़्यादा रेजिस्टेंस दिखाता है. इट शोज़ हायर रेजिस्टेंस टू chemical reaction. Second point, it has low heat of hydration and low shrinkage on drying. Okay, now that is obvious. If अगर सीमेंट का प्रॉपर सीमेंट हमने 70% ही लगाया है and 30% is pozzolanic material. Okay, it is like a siliceous material, like a soil type of material. Okay, तो ऑब्वियसली अगर ओपीसी का कंटेंट हमने कम किया, ठीक है, तो ऑब्वियसली हाइड्रेशन रिएक्शन भी थोड़ा कम होगा और बिकॉज ऑफ विच हीट ऑफ हाइड्रेशन भी थोड़ा कम होंगे. सो दैट्स वाई लो हीट ऑफ हाइड्रेशन कंपेयर टू ओपीसी. ओके, and low shrinkage on drying. Okay, then other point, it also improves water tightness and fire resistance qualities of the concrete. Okay, so even fire resistance, like the concrete becomes more, cement becomes more concrete. And last part, it is cheaper than OPC. Now this is the best part, it has better properties also, plus it is cheaper than OPC. Now let us see the uses. Pozzolana are used in mass concrete works such as in dam construction, massive foundation and bridges. Okay, mainly because pozzolana Portland cement also produces low heat of hydration, because of which we can use in mass concrete works. Then in sewer and sewage disposal works, even in sewer or sewage pipes वगैरह बनाने में भी PPC use कर सकते. Why? Because it has higher resistance to chemical attack and all. Last one, it is mainly used in marines and hydraulic structures also. Okay, so any structures that is made, you know, in the water or in the sea water, ठीक है, in the such situation also we can use PPC, because PPC, why? Because it shows greater resistance to chemicals found in seawater. Excuse me. So, so students, so students, we'll keep our lecture up to here only, and next class we'll continue with sulfate resisting cement, and there are 2 3 more types of cement that's being left. Okay, I hope you um, I hope you understood today's lecture. If you have any problem, any doubt, please let me know. And also, don't forget to go through once, okay? Because this is your mainly theoretical chapter, and you need to revise it every day, understand and learn. Okay? Thank you.